Good morning, everyone. Today, I will give you a presentation about the safety solution of solid-state lithium battery. Why there is this topic? Because we all know that nowadays, the lithium battery is highly related with our daily life, like the cars, the boat, the airplane, and also even the bicycle in China. Most of them are powered by lithium battery, and the data center, the energy storage system with the global application of the lithium battery, there are a lot of safety problems. Every year, there will be a lot of fire and explosion, which will cause a big loss to the wells. And today's topic, there are 5 parts. First, let me give you some introduction of the solid-state lithium battery. Although it is not a new technology, it has been introduced by the researchers all over the world for many years, especially the researchers in China, in Europe, in America, in Canada, and in Korea. All of this part, they do a lot of research about the solid-state electrolyte. The solid-state lithium battery, why we call it solid-state? Because the electrolyte used is solid. Nowadays, the present lithium battery is so highly used. Why we want to develop a new one? Because this one, it has some shortcomings. The first one is the safety problem. If there is thermal runaway, there will be big fire or the explosion. It will cause a lot of loss. According to the research all over the world, the basic reason of the thermal runaway is the liquid electrolyte used because this liquid is flammable. If there is overcharge or other problems like shortcoming inside, there will be some temperature rise within the battery, which will cause the SEI membrane to decompose to generate some flammable gas. When the flammable gas accumulated, it will cause the temperature to rise further, which will cause the liquid electrolyte get into fire. By this point, the thermal runaway cannot be controlled. We can only sit here and watch it to burn out. For everything, there can be burned. So that's the first reason. The other reason is that the lithium battery nowadays, the power cannot reach the power density of the oil-powered cars. Just like me, I do not want to drive a car powered by lithium battery because if I drive this car, I usually look at how many miles it can run. If I use an oil-powered car, I do not have this worry because if the oil is used up, there is some oil station, it can be fully charged within 5 minutes. But nowadays, for the present lithium battery, we cannot fully charge the battery at such a high rate. So those are the 2 shortcomings of the present lithium battery. So we want to develop a new one. If we want a safer battery to prevent thermal runaway, to prevent fire, the basic one is to get rid of the flammable liquid electrolyte. If there's nothing that is flammable, so how can fire get out? So nowadays, there are 3 types of solid-state electrolyte: the sulfide-based, the oxide-based, and also the polymer-based. We cannot say one is better than another. A lot of the manual researchers all over the world, they put more focus on the sulfide-based electrolyte. Why? Because the biggest advantage of this one is the high cost. And if this electrolyte meets with water, hydrogen sulfide, this toxic gas will be generated. That are the 2 biggest disadvantages. But its advantages is that it has high ionic conductivity, almost similar to the liquid electrolyte. Only when it has high ionic conductivity can it high energy density. And solid state, we hope that the electrode and the electrolyte, they can stick to each other tightly. Only by this we can have good performance. And this one, it can meet the requirement. It has very excellent low temperature performance. Nowadays, the present lithium battery, they have fewer application in the north part or the cold part, because when the temperature is low, the miles that the car can run, it is significantly reduced. And for the oxide basis and polymer basis, their biggest advantage are their safety. They are cheap and they are easy to be produced in big batch. But the disadvantages they have poor performance at low and high temperature, and they cannot have high energy density. So if we want a new technology, we hope that first it must meet the requirement. If the only advantage is that it is cheap, but it cannot meet the requirement, I don't think it has the market. So that's the three electrolyte. So today's presentation focused on the sulfide basis. This is the process of a solid-state lithium battery from the production of the electrolyte and the assembly of the battery and also the shipment, storage of the battery and the electrolyte. During the whole process, there is the risk of hydrogen sulfide generation, because when the package, there's some problem with the package, the electrolyte get into touch with the moisture in the air, hydrogen sulfide will be generated, which is very toxic to people. So we need to monitor the hydrogen sulfide concentration continuously. So we need a gas sensor. Only a gas sensor can give us this protection. Now, which principle can be used to detect H2S? There are 5 principles: fuel cell, electrochemical, NDIR, thermal conductivity, and also the MOX. There are these principles. Let's first start with electrochemical sensor. Why? Because this is the most widely used principle for H2S. And H2S sensor is now one of the most popular used sensor all over the world. It has so many applications in industry safety, and most of them are based on the electrochemical principle. Here, it has 3 electrodes: the working electrode, the counter electrode, and the reference electrode. When there is hydrogen sulfide, the hydrogen sulfide will react at the working electrode and oxygen at the counter electrode. The chemical equation between these 2 electrodes, it will generate some current. The current will be detected between the working and the reference electrode. Why there need a reference electrode? Because in the past, the sensor, if it only has working and counter electrode, it has a serious problem of polarization. What is polarization? Polarization means if there is a high concentration of hydrogen sulfide, the output cannot be stable. It may become smaller and smaller. So it cannot give a continuous, accurate detection. So we just use the reference electrode to solve this problem. This one is widely used in industry safety. But is there some shortcomings with this technology? The answer is yes. All this blank part, it is filled with liquid electrolyte, which usually at a certain humidity. And here, there is a big pore that the electrolyte can exchange with the outside freely. If the outside humidity is higher than the inner part, the water will be absorbed inside. Too much water gets in, the package will be cracked. The sensor just lose its function. And if the outside humidity is lower than the inner part, the water within the electrolyte will just go out. The inner part, if there is not enough electrolyte, it also will cause the sensitivity drift seriously. So if we look at the data sheet of the supplier of electrochemical H2S sensor, we can see that they usually say the sensitivity drift is about 1 to 2% per month. That means every year it has about 20% sensitivity drift, and its lifetime is usually about 2 years. So when this sensor is used in industry safety field, the sensor or the detector is taken back to the laboratory for recalibration once per year. It can be realized because in the industry safety application, every factory, it has its own laboratory for the recalibration of this. And there are some cases that they just use the portable detector, which is more easy for the recalibration. And this sensor, since it uses liquid electrolyte, its working temperature is usually around 50 centigrade. It will be very difficult to reach 70 centigrade, so that's the shortcoming. But the biggest advantage of this one is that it has a very fast response to hydrogen sulfide, so it is widely used in industry safety. And this one is the fuel cell technology. When you look at this, you can just think that you are looking at a small solid-state lithium battery. Why? Because for a solid-state lithium battery, it has 2 electrodes and 1 solid electrolyte. Here, we have 2 electrodes and the solid-state electrolyte within this sensor. The difference is the working and counter-electrode material or the catalyst and the type of the electrolyte. That's the difference, but the principle is almost totally the same. This one, it is zero power consumption. It is ideal for the application that require low power consumption. And since this one has very low noise and high signal and noise ratio, it is ideal for the application with long life and high precision. This one in the past is usually used in electrical industry, like to detect hydrogen of a big transformer and carbon monoxide generated in the big transformer. For the hydrogen sulfide detection, maybe our ProSense is the first one that use this technology to detect hydrogen sulfide. And these are another 2 technology, that is the MOX or semiconductor sensor and also the catalytic combustion sensor. This one, we can think that they are 2 brothers of a family because both of these 2 sensors, they must be heated to a very high temperature to realize the detection function. The difference is that for the MOX sensor, there is only 1 pellister. There is a platinum wire to provide heat, and around this platinum wire, it is coated with semiconductive material. With this material, it has some pores. The gas can be absorbed on this material, which will cause the conductivity of the material changed. By detection the changeness of the conductivity, we can determine the concentration. And this is the working principle of this one. And for this one, there are 2 pellisters, one with a catalyst and the other without. There is a Houston bridge. When there are some flammable gas arrives, it can react at the pellister with catalyst, which will cause the temperature of this pellister to raise, and the Houston bridge will lose its balance and voltage will be generated. By detection this, we can detect the concentration of the flammable gas. These 2 are very popular used in the residential and commercial VOC and flammable gas detection. But all the standards, the UL standard, the EN standard, and the GB standard, they required that for these 2 principles, we must evaluate the sensor's ability to the H2S poison, anti-H2S poison ability. if the anti-poisoning ability is a performance requirement of this technology, so I think it is not suitable for the detection of this gas. But there are some companies that use this technology for the detection. And there's another technology called thermal conductivity. This one is very hot, especially in China recently, because there are some company, they claims that they can detect hydrogen with this technology as low as 100 ppm, and hydrogen sulfide as low as 2 ppm. So is this the reality? I don't think so, because in this sensor, there is also a huge temperature. Every gas, it has different thermal conductivity. When there's gas comes here, it will cause this bridge to lose its balance. It also will give out some signal. Let's look at the thermal conductivity coefficient of H2S. Is about 0.5. So with the similar, there are several gases like SF6 and carbon dioxide. They have similar coefficient. So if there are a lot of interference gas with similar coefficient, how can we say that it will not affect the detection? And there's another one we cannot forget, that is water, the moisture. It has very similar thermal conductivity coefficient, and the molecular in the air, it is very many. If we think that the air is very dry, as low as 5% relative humidity, but if we turn it into molecular of water, it is very much. It's much more than the hydrogen sulfide. So this technology, it will be seriously affected by the gas mixture, the content, and how many gases are there, what is the content, the ratio of every gas, and what is the humidity. If the humidity and the temperature is very stable, this one, it can detect a very low concentration, but it is impossible in the real application. This is the NDIR and the TD-LAS technology. The hydrogen sulfide, they have very little absorption in this field, so this true technology has never been used in this field. Now let's check the requirement of the H2S sensor for the solid-state lithium battery, because all of the technology or the principle, they have application in different fields. We cannot say one technology is better than the other. We can only say that which technology is more suitable for a certain application. We can only say this. So what is the requirement for this sensor for the lithium battery? When the lithium battery, no matter it is used in cars or in the energy storage system, I think temperature is very important, because just we think that our car is parked outside and the sun is shining. The inner temperature is usually reached 90 centigrade. So for this application, the temperature range must be from -40 to at least 85 or 105 or even 125. This is the requirement of the temperature range. And also the lifetime. A car or an energy storage system, they can work for more than 10 years. We cannot require the driver, the car, the owner, just to take back the car to the factory to change this sensor. So the lifetime must be more than 10 years. And also it should have selectivity to hydrogen sulfide, because there are a lot of interference gases like silicon, like VOC, like carbon monoxide, and SO2, and the other gases. It should have selectivity to H2S, or it will give fault alarm all the time, which will cause a lot of problem. And among all these, I think only the fuel cell technology is the best suitable one, because for the electrochemical, the lifetime and the working temperature range is its shortcomings. And for the MOX, the zero drift, offset drift, and the silicon poison is the big problem with this technology. And for the thermal conductivity, the accuracy and the selectivity is the problem. For the NDIR, also the accuracy. So only the fuel cell technology is the most suitable for this application. And this one, the sensor with this technology, has also passed the test of the top 3 lithium battery manufacturers in China. They have evaluated that, yes, fuel cell technology is the most suitable one. This is the requirement, the detailed requirement for the sensor. From this, we can say only fuel cell can meet this requirement. And these are some test data. This is the storage at 70 centigrade. The sensors are stored at 70 centigrade and taken out to check the sensitivity drift from time to time. The upper line is fuel cell, and the lower line is the electrochemical. We can see that this one, when the temperature is high, the sensitivity drifts seriously. And these are the storage of the fuel cell sensor at 85 centigrade and also 85 centigrade plus 85% relative humidity. It is very stable. And this is the working performance of the fuel cell sensor at 105, the offset drift and the sensitivity drift. Excellent. The test period is more than 1,000 hours. Just the requirement for the cars. And this one is the storage at low temperature, minus 40 centigrade. This one also the comparison between fuel cell and electrochemical sensor. We can see that even at low temperature, electrochemical sensor is sensitivity drift seriously. And these are the working performance of the fuel cell sensor at minus 40 centigrade offset drift and the sensitivity drift, also very excellent. And this one is the sensitivity drift at room temperature and also the sensitivity drift when the sensor working at 105 centigrade. They are very excellent. They can meet the requirement of this application. Here is the selectivity test of the MOX sensor. Why this one is picked up to show? Because there are a lot of manufacturers, they claimed that their sensor is more suitable for this application. Let's check that this sensor has a significant response to carbon monoxide, alcohol, and hydrogen sulfide. Only the carbon monoxide and alcohol will be the interference gas, so it has poor selectivity. But it's not because this sensor or this principle is not good. This sensor, it has more than 60% market in the residential VOC sensor because it's more suitable for that application. But for this application, it has the requirement of selectivity, so it failed. And this one is the selectivity test of the fuel cell sensor. This test, we start with the test to 50 ppm hydrogen sulfide, and then 2 hours exposure to the interference gas and 1 hour to the clean air. After all of these tests, we tested the sensor's response to 50 ppm hydrogen sulfide again. By this, we compared the sensitivity drift before and after the selectivity test. we can see that it has high selectivity to hydrogen sulfide, and after the test, the sensitivity drift is very small, is negligible. So this sensor has a very good selectivity, and these are the detailed data. And this one is the comparison with the electrochemical sensor. We can see electrochemical sensor, it also has a big interference from carbon monoxide and hydrogen and also alcohol. If we want to use the sensor, no matter which technology we want to use, we hope that it can give us an accurate result. If we hope an accurate result, please make sure that you need to make a temperature compensation, not only to the offset, but also to the sensitivity, because both of these two parameters, they are related with a different temperature. So please make compensation to offset drift and temperature drift and the sensitivity drift. And also, please check the repeatability and the linearity of the sensor you select. Next, I will introduce ProSense's H2S sensor for this field, dedicated for this field. We have two sensors. One is 100. The module is 100 because its detection range is 100. And another one is with the model of 5,000 because the detection range is 5,000. The 100 one, it is targeted for the application online, for the real application. So it has the working temperature range from -40 to 125 centigrade, and it has more than 50 years lifetime. And for this one, it is used for the production line. It only has 2 years lifetime, and the working temperature is also to 125. So that's the two sensors ProSense launched for this application. Now, there's a brief introduction of ProSense. ProSense now we are the committee member of UL 2075, 2034, and 2201 because our technique is highly recognized by UL. They hope that in their committee system, they have a gas sensor manufacturer that knows different technology well and can give them some advice. So we are the TC member of these three TC. And we only have 4 sensors. Why? Because we think if we want to do a sensor, want to develop a sensor, we hope that we can find some port to solve the pain point of the industry. That means if we want to develop a sensor, we hope that there are some technical parameters that only ProSense can reach. By this way, to compete with other manufacturers, we do not want to compete the market with the price battle. That is the worst way. So we have the 4 sensors. The UL recognized the CO sensor, UL recognized the hydrogen sensor, and the hydrogen sulfide sensor for the lithium battery industry, and also our formaldehyde sensor, which has more than 70% market share and has 6 years lifetime. All of these 4, now I think we are the number 1 because we just focus on the vertical application. Just like the CO sensor, it has a lot of application. We do not focus the application on industry safety because it is the word of the electrochemical sensor. Our fuel sensor, we just focus on the portable generator, the residential alarm, and the detector for BESS. By to do the thoroughly research about the vertical application, we can know that what performance is most desired for this application, and how we can solve the pinpoint of this industry. So that's the product line of ProSense. If we develop a sensor, we hope that it can be #1 in the world. And also we have some patents and some cooperation with the universities all over the world. And there's also another reason why we only have 4 sensors. During the past 10 years, our customer, there are new customers to join us. We never lose a customer because they trust the ProSense. Why? Because we make the catalyst, the electrode, the MEA by ourselves. All our sensors focus on the fuel cell technology, especially with solid state electrolyte. By this, we are the sole manufacturer of this hydrogen sulfide sensor with this technology. No matter the fuel cell technology or the solid electrolyte, we are the #1. We are the first or the sole sensor all over the world. And also we make our own catalyst. Maybe you think that for the carbon monoxide sensor and for the hydrogen sensor, we just use platinum. But platinum, different production route will generate different platinum particles, no matter the particle size or the crystal. So we just develop our own catalyst. By this, we can control the performance of our sensor. That is the heart of our sensor. That's all for this presentation, and this is our contacts. If you are interested with our company or our products, please contact with us. Thank you.